Now can you see the script?
Yes, sir.
So then let's start. As for that, today we'll be starting with both. Can you see the right?
Yes, sir.
Have you read about source theory in lower classes?
No,
Yeah, but you've forgotten how electrons are arranged. Bohr's postulate. Very well. Let's see then. Bohr's theory. So the postulate for Bohr is first point. Okay, now how many are there? Two is there? Two of you are doing the class. Electron revolve around the nucleus in certain specific circular orbits known as stationary orbit, where the angular momentum is an integral multiple of h by 2. The condition formula is going to be MPR, that is equal to n into h by 2, where n is equal to 1, 2, 3, dot, dot, dot. And what is this MPR? MPR is known as the angular angular momentum. The very important point, and the formula is also extremely. So now let us try to understand this. Now see, what did Rutherford say? Rutherford said that electrons are revolving around nucleus. Electrons revolve around the nucleus. This was said by Rutherford. So suppose this is the nucleus, then electron can revolve according to Rutherford's theory. It can go from here also. It can revolve here also. Then someone can tell no, this is how electron is going to revolve by this distance. That can also happen. Another one will say here. So basically, as you see, there are infinite number of paths possible. There can be infinite number of paths possible according to Rutherford. Now, Rutherford theory doesn't give us anything about how the path is going to be. It just said electrons revolve around the nucleus. How they are going to revolve and what distance they are going to revolve. Nothing of that sort was told by Radha. So this was a drawback also. The board said that only those paths will be done, only those paths will exist of this infinite number of paths. Only those paths will exist where this particular condition is set. That is MVR equal to N into H by 2 power. If this condition is satisfied, then that particular orbit is going to exist. Suppose if this orbit satisfies the condition, then here we can see an orbit. But if this one doesn't satisfy this condition, then we cannot see an orbit over here. Suppose if this one also doesn't satisfy, then this orbit doesn't exist. But we are seeing that actually an orbit at this distance will satisfy the equation. So then this orbit can exist. Like this, not every orbit can exist according to Bohr's. Not any radius or any orbit can actually exist. Only a certain orbits can exist. What are those certain orbits? Where the angular momentum is an integral multiple of h by 2. Matlab, this condition will be satisfied. MVR is equal to NH by 2. If this particular condition is satisfied, then we can say yes, that particular orbit can exist. Now the question is, what is this angular? So angular momentum is just like if you have in your linear motion velocity, acceleration, displacement, momentum, all these things are there. Similarly, when a body is moving in a rotational motion, in rotational motion, the concepts of acceleration, velocity cannot be applied. Why can they not be applied? It is because in rotation, the direction of the body is continuously changing. Consider the rotation of a fan. You will see that the direction of rotation is continuously changing. Suppose this is the rotation of the motion. When the body is over here, this is the direction. In the next moment, when the body comes over here, the direction is changed. So every second, the direction of the body is changing. If the direction is continuously changing, that means we cannot apply the concepts of velocity, acceleration, momentum. That is why in rotational motion, we apply the concept of angular momentum, angular acceleration, angular velocity. Angular concept is that angular momentum is nothing but angular momentum is the equivalent of velocity, sorry, of momentum in rotational motion. Just like in linear motion you have momentum, in rotational motion you have angular momentum. That's the angular momentum is equal to nh by 2 pi. Okay, so this is what you, and this is the first condition of. Is the condition clear to you? Kindly let me know.
Yes, sir.
Yes, sir.
That's it. So the basic condition is not you cannot see electron every orbit. Only certain orbits are possible. And what are those certain orbits? Where this particular condition that m is equal to nh by 2 pi, particular condition is satisfied. So it's a very important condition and a very important theory. So kindly remember this postulate. Comes in an exam. Now let us see the second, rather the second postulate. So the second postulate says, as long as the electron stays in stationary orbit, will neither gain nor lose. So normally you see again in Rutherford we learn that whenever a body is moving in a circular path, it will continuously give out energy. So this force theory says that as long it is staying in this orbit, that is the orbit which satisfies mvr is equal to nh by 2 pi. As long as the electron is staying in those particular stationary orbit, it is neither going to gain any energy nor is it going to lose energy. And the third point is when an electron, when an electron comes from one stationary orbit, one stationary orbit, another, only the energy is absorbed or emitted following Planck's equation. When an electron is jumping from one stationary orbit to another, only then we can see the energy is being absorbed or emitted following the Planck's equation. So suppose this is an electron, this is one orbit, and this is another orbit. I'm not drawing the complete orbit, just a part. So suppose if the electron is jumping from here to here, from lower orbit to higher orbit, require energy, absorb energy, absorb energy. And if suppose the electron jumps from high to low, high to low orbital or low shell, it is actually giving out energy. And this, how much energy will be accepted or given out, that will be done according to this Planck's equation. Remember the Planck's equation that we had done in the previous class. So it will be done with basis to the Planck's equation. How much whether energy is going to be absorbed or emitted, and how much of it is going to be absorbed, that will be determined on basis of the Planck's equation. Okay, is it clear? So this situation is kind of similar to think. Suppose if you are going by a stair, you go up with the staircase, then what do you see? You see that you will require energy because you feel tired. So here also the same thing. Here also the same thing. That when electron is jumping from lower level to higher level, we can see that the energy is being required. Whereas if you climb down there, at that time you do not require any energy as such. So here also that thing is only happening. That energy is being given out. So kindly let me know, do you have any difficulty? Hello.
No, sir.
Is it completely clear?
Yes, sir.
Okay. Because see, this one is very important. So if you have like the slightest bit of difficulty, you should certainly let me know. So these are the three postulates. So the first postulate or the first theory of Bohr is that electrons are not found everywhere. It is found only in some specific orbit. And what are those specific orbits? That these are those orbits where the angular momentum is an integral multiple of h by 2. So only in this orbit we are going to see that. Then he says that as long as the electron is staying in this stationary orbit, it is neither going to gain any energy nor is it going to lose any energy. And the third point is that when an electron jumps from one orbit to another, then it might absorb or emit it, and it will do so following the Planck's. So then that's it about the Bohr's theory. Now the thing is, the success of Bohr's theory does not only lie in giving this equation, giving this postulate. Bohr simply didn't just give this postulate. Bohr also did the mathematical calculation. What did he calculate? He calculated the radius, velocity, and the energy of the hydrogen atom. So Bohr calculated the radius, velocity, and the energy of the hydrogen atom using the theory, using his particular theory. And it was seen that the value that he calculated mathematically was found to be accurate with the experimentally observed value. So that means what? That if his calculation is coming out to be accurate, that means somewhere his theory is correct. That's why it came out accurate. So that is why now we see those calculations. But the thing about this calculation is have the derivation of those formulas. We just have the formula. We need to know the formula. So the formula is going to be R is equal to R is equal to 0.529 0.529 into n square by z. This is the formula for calculating the radius, and the unit is going to be in angstrom. So that means here we can say that R is directly proportional to n square by z. Now this formula is extremely important. It's extremely important formula. So R directly proportional to n square by z. Then how to calculate velocity? For velocity, the formula that we use is 2.3 into 10 to the power of 8 into z by n into z by n centimeters per second. So that means here we can write that velocity directly proportional to z by n. And for energy, the formula that we used minus 13.58 into z square by n electron volt per atom. Or if you want to represent it in kilojoule, then the formula will become minus 1312 into z by n kilojoule per. That means energy directly proportional to z square by n. So Bohr actually used this formula. He derived this formula, and the result that he got by using these formulas was found to be extremely accurate, was found to be very, very accurate. The experimentally observed value. So if when the mathematical calculation is becoming so much accurate with the experimental value, then it was basically concluded that the assumptions or the theory that he gave, postulates of board, must be correct. That is why calculation that was done, taking the help of the theory, is also correct. That's logic. And board actually calculated it is what for the hydrogen atom. So board made all this calculation using the hydrogen atom. Very important formula. And if you are thinking of giving the competitive examination after your class 12, then so this gets more important. So these are the formula. R is equal to 0.529, n squared by z angstrom. V is equal to 2.3 into 10 to the power of 8, z by n centimeter per second. And energy is equal to minus 13.58 z square by n square electron volt per atom. That is equal to minus 1312 z square by n square kilojoule per mole. So we can say radius directly proportional to n square by z, velocity directly proportional to z by n, and energy is directly proportional to z square by n square. Okay? So these are the formulas that you need to remember. Now let us see the drawback of both. So what was the drawback that particularly Bohr's theory had? Let us see. By the way, when do you have your half yearly examination normally?
The September.
Can the school will reopen in will start for the first term in July?
Yes.
You two will get just 2 month class before half yearly examination.
Yes, sir.
Then so not many chapters can be there in half yearly. Hardly 3 chapters. Because all these chapters are very big chapters.
Mm.
Now let us see the drawback of both. They're very big chapters. We have not still come like halfway to the chapter. We even haven't done half. Once we complete this board theory, can be said like we have done 45%. Drawbacks of board theory. So the first drawback is the board theory does not explain Bohr's theory does not explain the reason behind the quantization of angular momentum. the quantization of angular momentum. Now, what does this point mean? So, if you look into this first postulate, so what is Bohr actually doing over here? Bohr is actually fixing which particular orbit can exist and which orbit cannot exist. This is basically essentially what is happening in the first post theory or the first postulate of that Bohr is actually fixing which particular orbits can exist and which cannot exist. So this fixing is known as quantization. So that is why this condition is known as the Bohr's condition of quantization. So quantization doesn't mean anything. This is simply fixing. The Bohr is fixing the radius of the orbit, which particular orbits can exist using this condition. So that is why this is called the Bohr condition of quantization. So now the thing is that Bohr gave this theory, Bohr gave the condition, but actually Bohr didn't give any explanation of why it was done in his theory. He didn't even care to explain. He just gave this, that this is the condition, but he didn't explain why he has taken such a peculiar condition or what is the need for this condition in the theory. That was never explained by. So that's a very big drawback that you are giving a new theory, but you are leaving the explanation to it incomplete. So that's it. So that's the first drawback of Bohr's theory. That Bohr's theory does not explain the reason behind the quantization of angular momentum. Then let's see the next point. The next point is I told you that Bohr did his work with hydrogen atom, and it was seen that the calculated values, mathematically calculated values, were found to be accurate with the experimentally observed value. But sadly, the case was only applicable only to hydrogen. When some other scientists went to did the calculation for helium, lithium, or for any other atom, they found that now the values did not match. The mathematically obtained value and the experimentally obtained value, they did not match. So in that way, Bohr basically turned lucky that he did his experiment only with hydrogen. That's why Bohr's theory, Bohr's theory is applicable is only applicable to one electrons, one electron system মানে hydrogen, helium plus, lithium 2 plus, like this. Only one electron system it is applicable. For multi-electron system, the Bohr's theory fails. It can't explain. So the Bohr's theory is basically only applicable for a one electron system. Then the third point, that is the Bohr's theory could not explain the hyperfine splitting, the hyperfine splitting of spectral lines of spectral lines under higher resolution. Number two, in presence of magnetic field. Which is basically our Zeeman effect. And in presence of electric field, which is called the star difference. Now, see, this particular point is something that you cannot understand at this level because this is taught in very higher classes, either in the final year of BSc or in MS. The number four, you have Bohr's theory. Bohr's theory violated violated the Heisenberg uncertainty principle. The Heisenberg's uncertainty principle. Now, this is also something which we will read after a week, maybe after few classes after a week, maybe today only. In the next week, Wednesday, we will study about this Heisenberg uncertainty principle. So once we get to know the Heisenberg uncertainty, then we can easily explain why the Bohr's theory is violating. And the fifth point is that Bohr's theory considers the atomic structure considered the atomic structure to be 2D. However, in reality, atoms are three-dimensional. So this is another draw. That Bohr, actually, see, we have drawn the Bohr's theory with a two-dimensional concept from a pen and paper. But in reality, when they were seen using instrument, it was found that atoms are basically a three-dimensional. Bohr's theory could not explain the three-dimensional nature of atoms. So these are the major drawbacks of Bohr's theory. Of this, the first 2 points is something that we understand at this moment, but the last 3 points, 3, 4, and 5, this we will slowly understand as we go further inside this chapter. Then we can get an idea about it. So this is your Bohr's theory. Both the postulate and the drawbacks of Bohr's theory are important for your examination point of view. Okay, they come in your examination. School they give to write the postulates or the formulas also they ask MCQ based types of questions. So that's it about the Bohr's theory. Can you let me know whether you have any difficulties in this Bohr's theory part? Do you have any difficulties, any problem?
No, sir.
This is completely clear now.
Yes, sir.
And are you reading after I finish the lesson for each day? Are you just revising it in your home? Are you up to date with the
Ye-
chapter?
Yes, sir.
So that means if I randomly ask anything, you can answer.
Sir, I will try, sir.
Then let's just give me the exact answer. Just give me a brief idea. Like, okay, let's start with a very easy one. Just give me a brief idea what is actually happening in the Rutherford's experiment. What are the conclusion that was drawn from Rutherford? Explain it to me in your own words.
Sir,
Sir, there are large empty spaces within an atom.
Okay.
the backscattering occurs.
Okay. When does the backscattering occur?
So when they directly hit the nucleus.
And
Sir, collision with heavy mass.
collision with heavy mass. Okay. Then what will happen due to this collision with heavy mass?
So due to the collision, backscattering happens.
That was told that if the electron is going and directly hitting the nucleus, backscattering can happen. That is perfect. But you told 2 points. One is large empty spaces is there inside the atom, and another one is the point about backscattering. And what about another point? Because there were 3 points given in the Rutherford theory.
Sir, the positive charge are present in the atom.
It has to be present
With
in atom only, but we say in the nucleus, not in the atom. Atom is everything together is known as atom. Nucleus, electron, everything together is called that. It's certain. Present in atom only. Other is present in nucleus. That's the correct answer. Any other thing can you remember about the Rutherford theory? And then tell me about what is the value of Planck's constant. What is the value of Planck's constant? Planck's constant. What is the value of Planck's constant? This do you remember? Can you recall?
so 1 minute, sir. Uh, 6.6 into 10 to the power minus 34 joule.
Again. 6.6 into 10 to the power of minus 34 joule second. Okay, so have like a basic idea of what is temperature. So then let's see the next topic. Today I will just write down the formula. Oh, by the way, for the Friday's class, on Fridays your class will be from um, it will be a bit 30 minutes earlier, only for Fridays, 7:50 instead of 7:45. And the other 3 days, 7:45 is okay. But only for the Fridays, for every Friday, your class will be from 7:50. That means our next class on Friday, we will start at 7:50. Be ready accordingly. So now the next topic that you have is hydrogen spectrum. Now this is a thing from where you will certainly get numericals in your examination. There's like 95% chance of getting a numerical from this one, hydrogen spectrum. Hydrogen spectrum. Now see, we had learned about atomic spectrum in yesterday's class. And there I told you that every element has a characteristic spectrum. The spectra of each and every element is going to be different from the other. So we are actually going to see about the hydrogen spectra because we have it in our syllabus. So we are just going to study the hydrogen spectra in a bit detail. Now the thing is, it is not possible to remember so many values of wavelength like we saw for sodium in the last class at 5890 and 5896 angstrom. So that way hydrogen has a numerous number of wavelengths in which the spectra is observed. So that's why it is not possible to remember so many values of wavelength. That's why an equation was devised which would give us the wavelength of the spectral lines. And also it will help us in predicting the position of the spectral lines even before we do the experiment. So that particular equation is known as the Rydberg equation. That is called the Rydberg equation. And did you get your NCERT books by now? Or it's still unavailable?
No, sir.
They're not available.
Not available. So have you downloaded it from internet?
Sir, I have part 2 one, not part 1.
Okay, but you can download the part one for the time being. Okay, I will show you how to download. Because today I will just write down the reaction. So the Rydberg equation, the formula is, memorize this formula for Friday's class. Because we'll be doing numericals and apply this formula multiple times. That is, U bar is equal to 1 by lambda, that is equal to r z square into 1 by n1 square minus 1 by n2 1 by n1 square 1 by n2 square. So this is the Rydberg equation. It's a very important equation which you need to memorize it. So now let us see what each of the term of the equation means. So the first thing is, what is this R? R, so you are seeing it for the first time. What does this R mean? R is equal to, R is called the Rydberg constant. Rydberg constant. And the value of R is 109,678 per centimeter. Now see, this value is like too complicated to apply in numericals since we are doing it without calculator. So that's why for the numerical, we will use this value 1.1 into 10 to the power of 5 per centimeter. So that is equal to 1.1 into 10 to the power of 7 per meter. So this is the value of Rydberg's constant that you are going to apply in the numericals. So Rydberg constant is equal to 1.1 into 10 to the power 5 per centimeter, or we can say it as 1.1 into 10 to the power of 7 per meter. This is the value of Rydberg constant. Okay. What is Z? Z is the atomic number. This too we know. This is atomic number. What is wavelength? What is lambda? Lambda is wavelength. And nu bar, the wave number. Wave number. And what is this now? N1 and N2. What is N1 and N2? N1 and N2 is the initial and final orbit of the electron. How to get this N1 and N2? That will get clear when we do the numericals. So this is the Rydberg equation. Initial and final orbit of the electron. You should know this equation by the next class. Be very, very clear about this equation by the next class. So this is our Rydberg equation. The nu bar is equal to 1 by lambda equal to rz square into 1 by n1 square minus 1 by n2 square. R is equal to the Rydberg constant, which has a value of 1.1 into 10 to the power of 5 per centimeter. Z atomic number, lambda is wavelength, and nu bar is known as wavelength. N1 and N2 is the initial and final orbit of the electron. So what is the significance of this Rydberg equation? That using the Rydberg equation, we can actually get the value of the wavelength where the spectra will be observed. Using the Rydberg equation, we can easily determine the value of the wavelength where the spectra is going to be observed. So that is the main significance of Rydberg equation. So this is a very important equation for numericals. Kindly memorize it before the next class, because in next class we will discuss this Rydberg equation and we will do the numericals about this. So then that's it. And Friday, our class will be from 7:15 a.m. Before the scheduled time. It's from 7:15 from Friday. Only for Friday. Other days 7:45. Only on Fridays it will be 7:15. So was today's class clear to both of you? How many are there?
Sir, 2.
Okay, 2 are there. So was it clear to both of you?
Yes, sir.
Both theory
Yes, sir.
completely clear, and the formula that you need to remember. We'll do the numericals. Plenty of numericals can come by application of this formula, which we will do in the next class. Okay, so then that's it. I am disconnecting the call. No, I'm not disconnecting. Wait, I'm not disconnecting the call. Uh, I'm just trying first. Let me show you. Should I show you how to download the book, or you can download it?